Lesson 34, Recognizing and Extending Arithmetic Sequences. First off, let's look at some vocabulary words. A term of a sequence is just a number in a sequence. And a sequence is just a listing of numbers that follows a certain rule. So each individual number in that sequence would be a term of a sequence. And then we have an arithmetic sequence. This is just a sequence that has a constant difference between consecutive terms. So there's a certain rule where you are adding a certain number each time. Or if you think about it, going the opposite direction, the difference, you're subtracting the number in between the two, and that would be your common difference, which is our last term, the difference between the two terms in a sequence. So how do we know if it's an arithmetic sequence? We need to look at the pattern or the sequence and determine, is there a certain pattern? And the pattern has to increase or decrease at a constant amount. So if I look at 7 to 12, to 17 to 22, in order to find if there's a constant in there, we'll take the second term and we'll subtract the first term from it. That gives us 5. And go to the next one. 17 minus 12 gives us 5. And then next one, 22 minus 17 also gives us 5. So is this an arithmetic sequence? Yes, and the common difference is they're adding 5 each time. The next one, we got 3, 6, 12, 24. We subtract 6 minus 3, gives us 3. 12 minus 6 gives us 6. I can already stop right there because those are not the same. So no, this is not an arithmetic sequence because there is no constant difference. The next one, we have 11 to 4 to negative 3 to negative 10. If I take a 4 and I subtract 11, that gives us a negative 7. If I take a negative 3, subtract 4, that gives me a negative 7. If I take a negative 10 minus a negative 3, which really I'm adding 3, gives me a negative 7. So yes, this is an arithmetic sequence. The common difference is we're adding a negative 7, or you can think of it as subtracting 7. Next, 4, 8, 16, 32, 64. Do the 8 minus 4 gives us 4. 16 minus 8 gives me 8. So no, this is not an arithmetic sequence. There is no common difference. Next one, 6 minus 7 is negative 1. 5 minus 6 is negative 1. 4 minus 5 is negative 1. So yes, this is an arithmetic sequence. Common difference is we're adding a negative 1, or you can think of it as subtracting 1. On the next one here, we got 10, we got 12, 15, and 19. Take our two numbers, 12 minus 10 gives us 2, 15 minus 12 gives us 3. So no, this is not an arithmetic sequence. It has no common difference. Example 2, using a recursive formula. We use a recursive formula to find the first 4 terms of an arithmetic sequence where a subscript 1 equals negative 2 and the common difference d equals 7. And the arithmetic sequence you can see is listed here. A subscript n is equal to the a subscript n minus 1 plus d for the common difference. So you use the arithmetic sequence to find the next term in a sequence. And they're always going to give you the first term. And they all have to give you the common difference. If they don't have those two parts, then it'll be very difficult to find out what the sequence would be. So we just need to fill in the numbers there. So the recursive formula, we know that a subscript 1 is -2. So our first term is -2. Now if I want to find my second term, n, remember, is the number of terms. So I want to find the second term. That would have to be a 2 minus 1 plus the common difference, which is 7. So really I'm looking at the first term plus 7. So I would put a -2 in here plus my 7 will give me my second term. -2 plus 7 is a +5. And then to find the third term, I would take my previous term, which is 5, and then add 7 to it, which will give me 12. And the reason why I put the 5 is there because if I put the subscript 3, it'd be 3 minus 1, which is 2, which means our second term, which was 5. And then the fourth term, I can take my third term, 12, add 7, and I get 19. So my sequence would be -2, 5, 12, and 19. Next one, let's use the formula for this one. Our first term is 5. Our second term, and for this one, I would just take 5 minus 8. So 5 minus 8 would give us a -3. And the third term would be our -3 minus 8, which gives us a -11. And our fourth term, -11 minus 8, gives us a -19. So that would be our arithmetic sequence for that example. Next one, our first term is -3. The common difference is 4. So I take my -3 and I add 4, which gives us 1. Our third term, start with our 1, so that's our second term, plus our 4 gives us 5. And our fourth term, start with our third term, which is 5, add 4 to it, we would get 9. Example 3, finding the nth term of an arithmetic sequence. So here we want to find a specific term. And here we use the formula a subscript n equals the first term plus whatever term we're finding minus 1 times the common difference. So I already have everything plugged into the formula for us. We need to find the fourth and the 11th term. So to find the fourth term, I put a 4 in for n. And then I simplify it. So the fourth term would be 6 plus 3 times 2, which is 6. So the fourth term has to equal 12. Find the 11th term. Plug an 11 in for n. 6 plus 12 minus 1 times 2. So I have 6 plus 11 times 2 is 22. So the 11th term would be 28. Next one, use that same rule to find the 10th term of this sequence. Here they did not give us the common difference. We need to find the common difference. So I would take 11 minus 3, which gives us 8. So my common difference is 8. My first term is 3. So I need to find the 10th term. My first term is 3 plus 10 minus 1 times the common difference of 8. So the 10th term equal to 3 plus 9 times 8 is 72. The 10th term has to equal 75. And let's find the 10th term in this sequence. first term is 1/4. Trying to find the 10th term. The common difference, 3/4 minus 1/4 equals 2/4 or half. So now I have a to the 10th equals 1/4 plus 9 times half is 9/2. Need common denominators to add, so this would be 1/4 plus 18/4, which would give us an answer of 19/4. So our 10th term would be 19/4. Next one, find the 8th and 20th terms of this sequence. So the 8th term is -5 plus 8 minus 1 times a -2. So the 8th term is -5 plus 7 times a -2 is a -14. So the 8th term would be a -19. And then the next one, find the 20th term. -5 plus 20 minus 1 times a -2. 20th term would be -5 plus 19 times a -2. 19 times a -2 gives us a -38. So our 20th term would be a -43. Okay, find the 12th term of the sequence, 3, 10, 17. So do the same thing with this one. So A, find the 12th term. First term is 3 plus the 12 minus 1 times common difference is 7. So 3 plus 77 will give us our 12th term. So our 12th term would be 80. The 45th term, this sequence, first term is 3. 45 minus 1, common difference. 3 and 1/4 minus 3 is just 1/4. So we have 44 times 1/4 gives us 11. Plus the 3 would give us our 45th term. So this would have to be 14. Next one, use that same rule to find the 4th and 11th term. So a to the subscript 4, we got 14 plus 4 minus 1 times a -3. We got 14 plus 3 times a -3 is a -9. So the 14th term, or the 4th term, 4th term would be +5. And 11th term, 14 plus 11 minus 1 times -3. We got 14 plus 9 times a -3 gives us a -27. 11th term would give us a -13. Find the 10th term of this sequence. We have the 10th term, we got 1 plus 10 minus 1 times the common difference. 10 minus 1 is 9. So now I have 1 plus 81 gives us our 10th term. Our 10th term would have to be 82. Find the 11th term. This would be 2/3 plus 11 minus 1, common difference. 1 minus 2/3 is 1/3. So now I have 9 times, or 10 times 3 is 10 thirds. So we got 2 thirds plus 10 thirds gives us 12 thirds, which is equal to 4. An application problem. The first table at a reception seat will seat 9 guests, while each additional table will seat 6 more guests. Write a rule to model the situation. So to find the nth table, or the nth number of guests at a table, we would take our first term. So the first table has 9 plus the n minus 1, and the common difference from one table to the next is 6, because they have 6 more guests than the previous one. So that would be our rule. Now we're going to use that rule to find out how many guests we seated with 10 tables. So we're finding the 10th term. So I have 9 plus 10 minus 1 times the common difference of 6. So 9 plus 9 times 6 is 54. So 54 plus 9, our 10th table will have 63 guests. Next one, the first table at reception will seat 10 guests, while each additional table will seat 8 more guests. We need to write a rule. So A subscript n equals our first table, 10, plus n minus 1 times the common difference of 8. We use that to find out how many guests can be seated with 15 tables. So 10 plus 15 minus 1 times 8. So we have 14 times 8 plus 10. So 10 plus 112 give us our 15th table. So we would have a total guest of 122. On the last one, the flowers are purchased to put on tables at a reception. The head table needs to have 12 flowers and the other tables need to have 6 flowers each. Write a rule to model the situation. Okay, A subscript n, we get 12 flowers plus n minus 1, common difference is 6. We need to find it for 15 tables. So A subscript 15 equals 12 plus 12 minus 1 times 6. So we got 11 times 6 is 66 plus the 12. That would give us 78 flowers. So that is our lesson on arithmetic sequence.